Hello, I'm MC Toon. Today we're going to have a quick look at Bob Knodell's 15 degree per hour drift and how he scientifically analyzed the results. So let's get right to what Bob said.
But what we found is when we turned on that gyroscope, we found that we were picking up a drift, a 15 degree per hour drift.
Thanks, Bob. Well, that's no big deal. There's nothing wrong in science with trying something and failing. It happens all the time. It's how you respond to it that really matters. So let's see, what did Bob do when he discovered that the outcome he wanted isn't the outcome that he got?
Obviously, we were taken aback by that. Wow, that's kind of a problem, right?
No, Bob, that's not a problem. When you do science, you take the outcome, right? It's not a problem. You discovered that the Earth was rotating. No problem at all. But you can tell you're a little embarrassed about that because you didn't seek to find the truth. You sought to prove your bias, and you failed.
We obviously were not willing to accept that, and so we started looking for ways to disprove that it was actually registering the motion of the Earth and that it in fact was registering the motion of the sky.
Yeah, you weren't willing to accept that because you only had one outcome that was acceptable to you, and that was to prove your bias. But I'll give you this. When you do science, you iterate, you go again, you adjust things, you create a new hypothesis. So yeah, you created a new hypothesis that the gyroscope was measuring something else. This is actually good. And then what happened? Let's see.
So the next thing that we set out to do was to encase the fiber optic gyro in what's called a zero Gauss chamber to see if we could actually shield the energies being generated by the heaven. And we were unsuccessful with that, unfortunately.
Actually, you weren't unsuccessful. You were very successful in measuring the rotation of the Earth. You have a device that's designed to measure rotation. It measured rotation normally, how it's designed. You put it in a chamber to try to block something that nobody's ever heard of before. Didn't do it. You were successful in measuring the rotation of the Earth. Double confirmation. Good job.
So the next thing that we're going to try is encasing the entire apparatus in bismuth. If everything works well, I'd like to release it at the conference.
If everything works well, you'd like to release it at the conference. That was the Flat Earth Global Conference in 2018. I haven't seen any... Did you have any success in measuring no rotation in a bismuth chamber? I don't know. Did you publish that? I know you tried several other ways to confirm your bias with that gyroscope, and I don't think you really did there, Bob, or you would have been all over the place publishing it. So what did happen, I think, is that you confirmed the rotation of the Earth. Good job. Now, Bob is not a scientist, and we don't need to look to Bob to see if the Earth is rotating. So what I've done is I've just compiled a list of scientific experiments that measure the rotation of the Earth. I put them on my website at mctoon.net/spin. It's many different types of tests, including gyroscope tests, as well as mechanical tests in multiple different methods, and they all confirm the same thing, a 15 degree per hour drift. So, sorry, Bob, your bias was not confirmed, and you found out the truth, that the Earth is rotating. Accept it, or I guess you don't want to be honest if you don't accept it. That's up to you.